Okay, in this video we're going to talk about transformations of a linear function. Alright, this is something they will ask usually on a test, and what they do is, first thing you need to know is a linear function is a line. It's just a line like you see on this little graph I have here. Alright, this I have drawn is the parent function. Alright, the linear parent function. The linear parent function is when y equals x. Alright, and that's what this is. And now that we call it function of x, we could say function of x equals x. Remember, f of x is the exact same thing as y. They're just the way they just say them. Alright, and so remember, this graph is the graph of the parent function, the linear parent function. Let me put linear, because we will do one later, quadratic. Alright, notice the linear parent function actually goes through the origin, alright? And it usually is a 1-to-1 ratio. What I mean by that, that's 1 and that would be 1. That would be 2 and that would be 2. So it goes through the origin, and you also could call this a direct variation. Alright, direct variation, remember, it goes through the origin as well. Alright, so that's the linear parent function. Alright, and so what we're going to do is we're going to how the line transforms. So otherwise, how does it shift left, right, up, down, steep, more, less steep? We're going to talk about some other words and what they mean. Alright, so let's look at, and I'm going to put a bunch of them up here and just try to do little examples of what it does and everything else. Alright, so like everything's going to be compared to these guys here, the parent function, every one of them. Alright, so here we go. I'm going to put in kind of like just how this works. Alright, so f of x, which you know is y, and we're going to say a So I'm going to put two of them up here just so you can see the difference in the two, and so that way it'll kind of like help you just see the difference in how we're reading it. Alright, so I just used two different variables, but basically they're the same. Alright, so notice the two different ones here. We have a f of x, and then we have f of bx. Alright, whenever you have a situation like this, like a number, now a represents a number. Alright, so like, let me give you an example, 2f of x, this one would be b 3x, like this. Alright, so when you see something like this. Alright, the a is a multiplier to the entire function. Alright, so a we multiply to the entire function. And then the b is multiplied just to the x value. Alright, so what this does really is it just changes the steepness of the line. So it just changes how fast it increases or decreases. Alright, so when these numbers, letters, or variables, when the a and b, I wish my pen would write great, sometimes it does and it doesn't. When a and b here are greater than 1, then it's more steep. Okay, and what we mean by that is the line, so like let's say we have this, there's our parent function, and I'm going to use a different color. When we say more steep, we mean the line's going to be steeper. It's going to be like this. Alright, and the bigger the number is, of course, the steeper it is. That's when a and b are greater than 1. Alright, now, if they're less than 1, alright, so when a and b are less than 1, like a fraction or decimal, so if a and b are less than or otherwise they're between 1 and they're a decimal or fraction. Let me write it like that because I don't want to say it's less than 1 when it could be negative. When it's between 0, oh my gosh, when it's between -1 and 1, okay, anything between -1 and 1, that's a fraction or a decimal, then the line is what we call less steep. So here we go, there's our parent function, and so when this happens, it's less steep. Otherwise, it's like it gets closer to being flat. So the closer it gets to 0, like a fraction decimal, the line gets more flat. If it hits 0, then it is flat. It's a flat line. There's no slope at 0. Alright, so there's that one. So the guys here, these that I've circled here, they're what causes it to be steep, less steep, And we're going to talk about compress and stretch here in a minute. All right, so we're going to go to another one. Let's change to another one. And I'm going to just erase this, and we're just going to kind of keep using the same page. All right, so remember we're comparing everything to the parent function. So like if I did this, we're going to come up with a problem, all right? And we're going to say 1/2 f of x. So what does this mean? All right, so compared to the parent function, so here is our graph. There's the parent function. I know it's not drawn on. Half, okay, is that number a decimal or fraction? Yes. Is it greater than 1 or greater than -1 or less than -1? No. So otherwise, the number 1, otherwise it's going to be less steep. That's what I'm trying to say. So because it's a fraction or decimal, it's going to be less steep. So it's going to look something like this. All right. If it was a negative, then it would be a negative downward, but it would be still less than 1. It would still be less steep. The negative just tells us which direction the line goes. The positive just tells us which way the line goes. But the number itself is what we're looking at. Okay. So if the number is less than 1, and we're talking about for both scenarios here, we're talking about for this one, both of those, it does the same thing. It causes it to be less steep, or if it was a bigger number, it would be more steep. All right, so now let's do the other one. What happens if we have a scenario like this? I'm going to say f of x, all right, and we're going to say f is x minus c, f of x, x plus c. All right, I'm going to do a couple more so you can see what I'm talking about. Okay, in these two scenarios, if you notice the parentheses, the letter, the variables C and D, C is inside the parentheses, okay, where D is outside the parentheses. All right, so when we have a scenario where we have a number with x inside the parentheses, just like you see x minus c, and I'm going to give you an example. What if I had something like this, x plus 10, all right, x plus 10, all right, and then what that does is this is telling me that I'm shifting over, I'm moving the thing. Now, I put x plus 10 when I meant x minus 10, sorry. X minus 10. All right, in this scenario, what we're saying is that whenever whenever the letter is inside the parentheses, you shift it to the left. So I'm going to use blue here to exonerate. So let's say that we have x minus 10. Remember, we're comparing it to the parent function. The parent function is 0. Now, most kids think, oh, we go to the left 10 units because it's a minus 10. Not in this case. In this case, because it's inside the parentheses, we're going to go to the right 10. And the reason why is because we want to make x a 0. We want to make that a 0. So I'm actually going to x minus 10. I'm going to move over 10 spots this way, and I'm going to shift my line like this. It'll be parallel to the old line, but it will be shifted that way 10. So we actually would shift, when it said x minus 10, we actually would go to the right 10. All right? If it's a plus, so for example, if it says x plus 3, okay, then we will actually, and I'll do a different color, black, we would shift it to the left 3 because negative 3 is going to give us a 0 inside the parentheses. So I'd actually go 1, 2, 3, and so I'd have a negative 3, which would be right here. So this would be fx plus 3. All right, and we shift it to the left. Actually, go this way. All right, so this is very important that you kind of make sure you study this or you kind of understand this. All right, so when this number is inside the parentheses, we go to left or right. If it's negative number, we go to the right. If it's a positive number, we go to the left. Now, look at the other one. The other one has a number outside the parentheses. When it's outside the parentheses, it goes up and down, but it goes up and down like it says. So if it's a positive, we're going to go up. If it's negative, we're going to go down. All right, so in this case, this one would go to the left, and this one would go to the right. Just kind of hopefully those arrows would help you in this situation to understand this a little better. So in this case, what if I had x? We just say x plus 3. Notice there's no parentheses. All right, so there's no parentheses, and I'm going to put an equal sign here so you know we have a f of x. X plus 3. So that means I just go up 3 units. So I'm going to use this in blue. So go. We're comparing it to the parent function. So I'm going to go up 3. 1, 2, 3. So it'd be up here. So this line would just go up to the third unit. All right. And then if I was doing negative, I would go down 3 units.